Good morning, student. Today in this video we are going to discuss about the fundamentals of algorithm. This is chapter 3, the fundamentals of algorithm. What is an algorithm? See, for example, you are going to your stakeholder, you are going to a library and you are asking, do you want any program? Then the librarian is giving you an idea that I need a program that whenever the students select the book or take the book, I want to make the entry on my system, and then I want to reduce the number, and I want a program that when the students should return. Now he is giving his ideas in English language, or he is giving in his language. What was the language? Maybe he is giving in a language. Now the programmer needs to convert this language, English language, into a programming language. From the spoken language, he has to convert into a programming language. He may be using any software. Maybe he may be using C, he may be using C++, he may be using Visual Basic, he may be using Java, he may be using Python, anything. We don't know what type of language he is going to use. But he is having a information in English. Now he wants to convert this into a programming language. Now in between this we need a structured intermediate program or a structured idea that will convert the English language into the programming language. We need a structured set of instruction. This structured set of instruction is called algorithm. This structured set of instruction is called algorithm. Previously we were using the natural algorithm by using step-by-step procedures, just what we have to do. In this chapter we are going to discuss another idea which is called pseudocode. Which is called pseudocode. This is nothing but more or less a programming language idea. You know, in earlier days, there are some softwares called Fortran, Pascal, and all. How they were writing the program. More or less the same idea we are going to use in this pseudocode. This is a structured algorithm. This will have all the ideas how we are going to convert or how we are going to write a program. How we are going to write a program in any programming language. Always the pseudocode will have a structure. It will start with a term called procedure. Always it starts with a term called procedure, and this will define the statement, what we are going to do in this program. Maybe I want to find some least value, or I want to add two numbers, I want to deduct something. So what is the procedure? What for? This procedure is what for? And this will have a set of instructions. This will have a set of instructions. Maybe a loop, maybe a conditional statement, whatever the requirement for related to the program. And then this will have an end statement. Then this will have an end statement. Using this idea, in this chapter, we are going to discuss some mathematical problems. See, for example, write an algorithm to find the maximum element from a finite sequence. First I am going to write an algorithm, then we will discuss a sample problem. What is the meaning of this? What is the requirement here? See, for example, I am having a set of numbers 7, 15, 12, 11, 19, 22, 15, 16, maybe something. I am having a set of numbers. From this set of numbers, I am going to find the maximum number. I am going to find the maximum number. How a computer system is going to identify the maximum number from this sequence. This is what we are going to discuss in this one. In pseudocode, we are going to write the algorithm. The pseudocode always starts with procedure. Always starts with procedure. When I say procedure, I am going to define what for this program is. This program, it is defining to find the maximum element. So I am going to write like this: max from the set of elements. We don't know how many elements are there. I don't know what are the numbers. So I am going to assume the numbers as A1, A2, A3 and so on up to An. I am having n numbers. And I am going to define the nature of these numbers. Whether the number is an integer or a real number, what type it is. For example, I am going to define the numbers are integer. From this set of n number, I am going to find the maximum number. I am having the set of numbers. From this, the computer is going to find the maximum number. How it is going to find that? So we have started with the procedure. In general, we don't know which is the big number. Maybe in the first position, second position, third position, we don't know. So what I am going to do, I am going to define a maximum, a variable called maximum to the first number. For example, if you take this as an example, I am going to take the maximum as 7. I don't know, I am assuming. And then what I am going to do, I am going to compare this number with the other numbers. I am going to compare this number with the other numbers, and then I am going to find which is the maximum number. So maximum equal, I have defined to A1. Now I am going to find, or I am going to compare with the other numbers. That means when I am going to compare the other numbers, there is a need for a loop. So I am going to write for I is equal to, already I took the first number, that means I am going to take from 2 to n. I am going to define from, starting from second number to the nth number. What I am going to do now? I am going to check whether this number is small or big, the maximum what I have defined. For example, I am going to take the 7, I am going to check with the next number whether 7 is big number or small number. If it is a small number, then I am going to change. That means the value will be interchanged. Otherwise, I am going to keep as it is. So for I is equal to 2 to n, I am going to compare, or I am going to check if max is less than, I am going to compare max is less than ai. That means maximum is the small number, ai is becoming a big number. That means this is the maximum number. I am going to interchange this, then I am going to make max equal ai. I am going to make max equal ai. This will be keep loop in a loop. It will work until the last number. Then it will check for 15. Then it will compare with the 15. So in this place, max will become 15. Correct? And then this 15 will be compared with 12. Then this 15 will be compared with 11. Then 19. Whenever we are getting the big number, the value will be automatically replaced. Value will be automatically replaced. And then finally, we will have the value of max as the big number. So I am going to return. I am going to return max. Because in max, we will have the maximum number. Max will have the maximum number, is the maximum number. So this is called pseudo code. This is called pseudocode. We are going to start with the procedure and we are going to make the programming. More or less, this is like a programming. This is called pseudocode. Let me discuss one more problem or one more idea. Write an algorithm to bubble sort a given finite sequence. How a computer system is going to find, or how a computer system is going to write a set of numbers in ascending order or descending order. See, for example, I am having a set of numbers 7, 11, 10, 9, 5. The computer, it has to check all the 5 numbers and at the end it should produce the value or the sequence 5, 7, 9, 10, 11. It has to produce in the order. How a computer system is going to produce this output? Now, in general, what happens when we are seeing it, we can say, oh, 5 is a small number and we can make it. But in the computer system, we cannot compare all the numbers simultaneously. So that means I am going to compare two numbers in each set and then we are going to produce the output. So here I am going to start with the procedure. What we are going to do? We are going to bubble sort. What we are going to bubble sort? We are going to sort the numbers A1, A2, A3 and so on, AN. These are all the real numbers with at least we need with n greater than, because we need the numbers which are at least more than 2 numbers, then only we can make the bubble sort. If we have 3 numbers, then only we can start making the bubble sort. Because if I have only 2 numbers, then 7 and 11, we can compare directly. There is no need of sorting. We can make the comparison and we can complete the answer. Here, what I am going to do, we need 2 set of loops. One, for the first set of loop, going to compare the overall and then comparing the intermediate. One for comparing the overall and for comparing the intermediate. So I am going to define for I equal 1 to n minus 1. Why? Because we are going to take the first one, 7 as it is. I am going to compare 7 with 11 and then I am going to make an order and then 11 and 10, 10 and 9 and 9 and 5. I am going to keep comparing one by one. So I am going to write like this: for I is equal to 1 to n minus 1. This is the first set of loop. This is the first set of loop. Now for the second set of loop, we are going to define another variable for j equal 1 to n minus I, because each and every time I am going to keep comparing the number to numbers. If aj is less than aj plus 1. When you want to write the numbers in small number to big number, we are going to use greater than, or if you want to write the number from big number to small number, we are going to use less than. If aj is greater than, this is for ascending order. This is for ascending order. For descending order, in the opposite. aj greater than aj plus 1, then I am going to interchange aj plus 1. I am going to interchange aj and aj plus 1. Here, please note, this symbol depends on whether you want ascending order or descending order. This symbol, this one, less than or greater than, depends on how you are going to arrange, whether you are going to write the number in ascending order or you are going to arrange in the descending order. Then finally we are going to return A1 the sequence, which will be the sequence. So this is called bubble sort algorithm. This is called bubble sort algorithm. In the next video we are going to compare some problems. I gave you some samples, isn't it? We are going to take the sample and how it will work in the computer programming. We are going to discuss this in the next video.